to see the 16-bit addition in 8086 processor using EMU 8086. So first we are opening the 8086 simulator. For update you give later, create a new file, click OK. So already a sample file will be available, delete all the codes. So we are going to do a 16-bit addition. For this 16-bit addition we need two operands and we have to place in A register and B register, and then we have to add. We are taking the data from the memory and we are storing the result to the memory. In 8086 we need the data segment for doing the process. So initially we are making the data segment to 0. For making the data segment to 0, we are using the accumulator move AX, comma, it is a 16-bit register. So we are giving a 16-bit number. So initially we are making accumulator 0. Then we are moving the data to DX, AX. Then we have to take the first data from the memory. So we are placing it in the accumulator. So we are taking the data from the 2000 memory location. So after that we are taking the second data from the memory. So it is from 2002. So both are 16-bit data. So in order to indicate the address, we are using the bracket. If there is no bracket, it is a data. If we are using bracket, it is a address. So then we have to add both AX and BX. The result will be in the AX. So we have to store the result in a memory location. It is a 16-bit data. So we are using the memory location 2004 H. Then we have to check the carry. If there is no carry, we have to give the carry memory location as 0. So we are using jump no carry CY. So it will go to the label CY. So CY. So I am using the memory location 2006 as 0, 00H. And final instruction is halt. We are using the instruction halt. So if there is a carry, then we are using the same memory location 2006 as 1. 2006 memory location as 1. Then we are going to the last location, jump exit. So exit is a label which is corresponding to the last location. Okay. So what we are doing is initially we are making the accumulator 0, so that we are making the data segment also 0. Then we are taking the first operand in the AX, we are taking the second operand in the BX, adding both AX and BX. Then we are storing the result in the 2004 and we are checking for carry. If there is no carry, we are storing the location 2000H as 00 and halt. If there is carry, we are making the memory location 01 to indicate the carry and jump exit. So this is a 16-bit addition in 8086 processor. Then we have to go to the emulate. So this windows will be available, and then we have to give the data for this. So this is the data segment address and this is the actual memory location address. For data segment address we are giving 000 and memory location we are giving 2000. Then you have to place enter. So the memory location 2000 will be available. So I am giving a data of 15. Similarly 2001 also I am giving 15. For second data 25. Here also 25. So it is a 16-bit data. So 1515 is a 16-bit data. 2525 is also a 16-bit data. Now if you look at this simulator, you have AX register, BX register, CX, DX, instruction pointer, code segment, stack pointers, base pointer, source index, destination index, data segment, extra segment, though these all the values are available. We can see what is the value while running the instruction step by step. So in order to run the instruction program step by step, we go to the single step operation. So if we go to the run operation, it will execute at once. If we go for the single step operation, it will execute one by one. So I am using the operation single step. So first instruction is AX00. So it will be 00. Then so now DS becomes 000. So whatever value in the AX becomes DX. So DX will be clear. It is pointing the location value of 000. Next instruction. So 1515 is loaded in the AX register. So after executing the next instruction, BX will be loaded with 2525. Now, so after adding AX and BX, so AX becomes 3A and 3A because 15 plus 25 in hexadecimal is 3A. So both of becomes 3A, 3A. Here there is no carry. So it will go to the location 000 and it finally comes out from the program. So in order to view the result, you once again go to the memory location. Data segment value is 000 and actual memory location is 2000. Give enter. So when you give 15 plus 15, it is 3A. 15 plus 25, 3A. 15 plus 25, 3A. Here there is no carry. So 2006 is a no carry. So it is a simple addition program. We can see the results by using this simulator itself. Thank you.